Welcome to a lesson, Dr. Powell. Let's take a look at an example of testing a series for convergence, divergence. Suppose we have 2 to the n over n factorial. So n goes from 0 up to infinity. All right. Now, what is n factorial? This simply means, well, just via some examples, like 3 factorial equals 3 times 2 times 1. 5 factorial equals 5 times 4 times 3 times 2 times 1. So even in the name factorial, it wants like all the factors 1 through up to this number. Now, this also counts how many permutations there are of 5 things. So here's an idea. 0 factorial is equal to 1 because there's one way of permuting or rearranging 0 things. That is to do nothing. One way. But we simply think of this as being the empty product, 1. 1 factorial of course, is 1. Okay, so now using that idea, knowing what factorial means, let's think about what strategy we could use. Now, if we were thinking of an alternating series type test, we'd have to kind of think about taking a limit or seeing if this is decreasing. Let's actually do a little bit better than that. Let's actually test for absolute convergence. If it absolutely converges, then of course it'll actually conditionally converge as well. So let's test that, taking the absolute value. So we just look at 2 to the n over n factorial. And let's just do a comparison, compare it to something. Let's rewrite this as 2 over n times 2 over n minus 1 times 2 over n minus 2 times ... all the way to 2, let's do 2 over 3 times 2 over 2 times 2 over 1. Notice that there are n things on the bottom and n things on the top, just as desired here. Now, keep in mind that all the fractions that I've written out from here to here are less than 1. So when we multiply by any of these fractions, it actually makes what we have smaller. In particular, let's just kind of group the middle section. This is a fraction that's less than 1, which means that this whole thing is less than just the first 2 guys times the last 2 guys, which is simply 8 over n times n minus 1. This actually bounds everything we have here above, 2 to the n over n factorial. So since it's bounded above by this, and this is 8 over n squared minus n, and we know that that this is greater than or equal to 8 over a half of, let's see, n squared. Since we want this guy to be smaller than this, right? And eventually we can't be 1/2 of n squared, so is going to be smaller than taking n away, because n is going to be very negligible compared to n squared. So this is okay. So then that's going to be 16 over n squared. So eventually this, via asymptotic inequality, this is eventually less than that, and we know that 1 over n squared converges by a p-test, which means that this converges absolutely. And if this converges absolutely, then for sure this will converge conditionally. The alternating series will converge as well, because if the absolute values converge, that implies that it's conditionally convergent as well. Because if everything is positive and it's converging, then if you're making some of them negative, you're kind of decreasing the size of the absolute value from what it would be if they were all positive anyhow. And you're making it smaller, so it'll be kind of sandwiched in there. It will converge. Okay, so with that, that concludes that example. Thanks for watching.